All right, section 1.4 is all about area and perimeter, and in this case, in the coordinate plane. Before we talk about area and perimeter, though, it does mention briefly we have two different types of polygons, convex and concave. A concave polygon is, I usually think of it as something that's caved in on one side, and then convex is just not caved in. This one here is also a hexagon, and this one over here is a pentagon. But moving on to area and perimeter, we'll start with perimeter. Perimeter is the distance around a polygon. So if I were to walk all the way around the edges of the perimeter, we can also think of it as just adding together all the side lengths. And if the side lengths are vertical or horizontal, it's pretty easy to figure out what they are. They just count spaces, 5 spaces here, 4 spaces here, 5 plus 4. If a side is diagonal, then we're going to have to use the Pythagorean theorem to figure out the length of that side. In this case, the perimeter is 5 plus 4 plus the square root of 41. And I changed it to this wavy equal sign, which means approximately, because I had to round off square root of 41 to 6.40. So our perimeter is approximately to the nearest hundredth, 15.40. And there's our Pythagorean theorem work down here at the bottom. And next up we have area in the coordinate plane. First, area of a rectangle. Area of a rectangle is length times width. And if the rectangle is sitting in the coordinate plane like this one is, where the sides are all along the grid lines, it's pretty easy. We just count spaces and we get an area of 28 square units, because it's 7 by 4, 7 times 4 is 28 square units. We also have area of a triangle. The formula for area of a triangle is 1/2 base times height. If you notice here, this right triangle is half of a larger rectangle, so it would be base times height, but then half of that, 1/2 base times height. Since the triangle is seated nicely in the coordinate plane, so it's along the grid lines, the base is 5, the height is 4. I could also have said, I suppose, that the base was 4 and the height was 5. It doesn't really matter. So then we'd have 5 times 4 times 1/2, 10 square units. Moving on. We're frequently going to come across shapes that are a little more complicated than just rectangles and squares. And we have two methods in the grid for figuring out their areas. One, it's called the boxing in method, and the other one I'd call the cutting up method. These aren't exactly like technical terms. That's just kind of words I came up with, or maybe I saw somewhere. I don't know. First, the boxing in method. The boxing in method basically has us box in the shape with triangles and rectangles, typically triangles, to make a larger rectangle. So I've got this blue outline shape here. It's kind of an odd shape. There's no simple formula for finding its area. So what I do is I just add these triangles, 1, 2, and 3, so that I get a larger rectangle, which in this case also happens to be a square. So the area of that square is 6 by 6, or 36 square units. And then the 3 triangles separately, go down here, triangles 1, 2, and 3, they're all right triangles, easy to find the areas. So I've got 3 square units, 6 square units, 9 square units, for a total of 18 square units. So then I take my area of the rectangle, and that's the large rectangle here, and I subtract the areas of the triangles, and I'm left in the end with whatever the area was of the shape that I started with. So I box it in, I calculate the area of the overall box, and then I subtract the areas of the triangles, or sometimes you'll have to add little rectangles on the side or whatever. All right, next we have the cutting up method. So here's another sort of oddball shape that doesn't have a simple formula, but what we're going to do is we're going to cut it up into several smaller shapes, in this case 2 triangles and a rectangle that we can easily find the areas of. So the area of the overall shape is the area of all the smaller shapes added up. So in this case, if you go down here and take a look, here is calculating the area of shape number 1. It's a triangle. We got 4 square units. Calculating the area of shape 2, it's a rectangle, 20 square units. Calculating the area of shape 3, another triangle, 7 square units. So then we take all those and we add them up. 4 plus 20 plus 7 gives us 31 square units altogether. Now pretty much any shape, any polygon shape in the grid can either be cut up or boxed in to find its area. It's just however you see each particular shape, what you like better, either method will work. All right, and I think that's it for area and perimeter in the coordinate plane. You're ready to do some practice problems.